Hello everyone and welcome back. In the previous session, we discussed some of the mathematics that powers deep learning. We talked about few mathematical concepts such as vectors, matrices, activation functions, loss functions, and other things such as gradient descents. Now, some of you might be wondering, why are we learning all these maths? The answer is simple. Because everything inside machine learning and deep learning is ultimately numbers and matrix operations. Today, we will actually see that in action. We will start with NumPy and matrix multiplication and then build the first real classification model using the famous datasets. Let's begin. Before building AI models, we need a way to work with numbers directly. That's where NumPy comes in. NumPy stands for Numerical Python. Almost every machine learning library internally uses NumPy arrays. And let's start with it. First of all, we are going to import the library. Then we are going to create a data set or of arrays of numbers. We are going to print it and then we are going to perform few mathematical operations. To our code of day 2, the session of deep learning. First of all, let us write about the topic name, which is NumPy. Then we will start by importing the library, which is import NumPy as np. Okay, let us run it. So the library is getting imported. First of all, the session is going to start in which it will be connected to the hardware present on Google's machines, Google's drives, and then the things will be loaded. Okay, the NumPy library has been imported and now we can begin our coding with NumPy. So first of all, I am going to create an array. Let's say I create an array as A. So A equals np.array, and in that I am going to write 1 2 3. Okay, array of 3 numbers. Then I am going to print, and here I am going to write, let's say here I am going to write, let's say array array. Okay, array, and in the next line I want to print the array A. Okay, so this will print the array A. Let us run this. The array has been printed. Okay, so array is 1 2 and 3. Now let us move on to find out the shape of the array. So to find the shape of array, I'll just simply write print in bracket a dot shape. So this is going to return as 3 because 3 comma 0 or only 3 because it is one dimensional array and it contains 3 elements. Now, if I want to perform few mathematical expressions such as arrays multiplication or addition of certain number to array. So how am I going to perform that? I am just going to add a line print, and in bracket I am going to write a star 2 to multiply it with 2, and print, and in bracket a plus 5, or let's say I write 8, a plus 8. So it is going to add all the numbers with 8. Control enter, and it is going to print me 2 4 6. So the numbers 1 2 3 were multiplied by 2 to give us 2 4 and 6. Then the a plus 8, it gave 1 plus 8, 2 plus 8 and 3 plus 8, which is 1 plus 8 is 9, 2 plus 8 is 10 and 3 plus 8 is 11. So that is how we perform the mathematical expressions on the arrays. Now we will move on to the next part. So before moving on to the next part, let us clear a few points first. Did you guys understand what just happened? Yesterday we just discussed about features. Imagine these values are representing, let's say, age, or let's say incomes, or let's say experiences. A vector is simply a collection of values. In AI, vectors are everywhere. Images become vectors, audio becomes a vector, even text and sensor readings become vector. Everything eventually becomes numbers. Now let us move on to matrices. So how are we going to import matrices? So first of all, we are going to, yesterday, as I mentioned, that neural networks perform operations on large numbers, which includes matrix multiplication. And today we are also going to see one. So let us start by doing it. So first of all, let me add a code here. And in code, okay, let us add a text box which features matrix, matrix, multiplication. Okay. So when I added matrix multiplication, I'll add a code line here which will say, let's say I am defining an array A, which is a matrix. So how are we defining a matrix? np.array, np.array, and inside array I am going to write the matrix which will be in the form of 2 comma 2, that is 2 rows and 2 columns. So in this I am first going to write the first column, which is the heading 1 comma 2, and then I will move on to write the second one, which is 2 comma 4, let's say. Okay, so this completes my matrix. Let us define another matrix as well. Let's say we call it B, and B is, let's say, here also np dot array. Okay, and this matrix will be presented as, let's say, 5 7 and 6 8. Okay, so this will be presented as 5 comma 7. Okay, and then 5 comma 7, and then 6 comma 8. 6 comma 8. Okay, so these two matrices have been defined, the first one being A 1 3 2 4, and the second one B, which is 5 7 6 8. Now first of all, let us look at matrix A followed by matrix B, and then we will do the dot product and cross product as well. Okay, so print, and in print I am going to write matrix A. Okay, and print, and here I am going to print A. Similarly, I'll have to do it for B as well. So for B as well, I'm going to write it as here B, and here as well B. Then we are going to print the dot product. For dot, we need result, which will be represented as np dot dot p dot, and in dot we'll write A comma B. Okay, so first of all, our matrix A will be printed, followed by matrix B, and we will get the result, which is dot product of both these A and B, and I am going to print result. Okay, print result. Yes, when I run this, my matrix A here is 1 3 2 4, 1 3 2 4, matrix B is 5 7 6 8, and my result is 23 31 34 and 46. So these are my answers to the matrix multiplication. So this is the thing that goes on inside matrix multiplication whenever the images or audio or any signal gets converted into the matrix form. Now students may ask, why do we exactly need multiplication? Which is a great question. Inside a neural network, every neuron is connected to many other neurons. When the data moves through these networks, matrix multiplication is happening continuously. In fact, most of the heavy computation inside the deep learning is matrix multiplication. Therefore, the GPUs are so powerful for AI. The reason why they are so powerful is because they are extremely good at matrix operations. So whenever you hear someone talking about training neural networks on GPUs, this is one of the major reasons why GPUs are preferred in while using or training or testing AIs. Now that we have seen the vectors and matrices, let's build our first machine learning classifier. Today we are going to solve a real world problem. We are going to predict the species of flower. And this dataset is so famous that almost every machine learning engineer starts with it. It is called the iris dataset. So what exactly is this dataset? This particular iris dataset consists of measurements of flowers. Specifically, it will give us the sepals length, the width, the petals length, the petals width, and by combining these measurements, we will predict the species of flower which the flower belongs to. There are three major species of iris. The first one being setosa. The second is versicolor, and the third is virginica. So first of all, before writing the code, let's connect this to yesterday's concepts, which were the first one being the feature and the second one being the labels. So what exactly are the features? So the features are the inputs. And in this particular data set, what will be the features? The features will be the sepal's length, its width, and the petal's length and its width. And the second thing, what are the labels? Labels are the answers to the question which are posed by the dataset or the features. And what are these going to be? The classification of flowers. The three major types of iris flowers are setosa, versicolor, and virginica. So these are the labels. Labels. And most important thing is to remember is features are the questions and labels are the answers. And every machine learning problems solves the following idea. So now let us begin with our dataset by importing few libraries and then starting to work on them. So let us write our first text box, which is iris classification. Iris classification. So first of all, we are going to import few libraries. So what are these libraries? From sklearn dot datasets import datasets import load underscore iris. So the dataset has been loaded from sklearn dot model underscore selection import train test split, and then from sklearn under sorry dot neighbors nei neighbors import k neighbors classifier. So this is the machine learning model that we are going to use, and from sklearn dot metrics import accuracy score. Okay, so these are the important libraries that we need to fetch from sklearn. Sklearn is the classical library which is used to train machine learning models or to get the classifiers or to get different matrices as well. So it is the Bible for machine learning. So we will run it. So the green arrow or green tick means it has completely, the task has been completed. Now we will first of all load the iris. So we will write iris equals load underscore iris. Okay. So this iris is the variable and we have assigned load iris to it. We will run it. So this has completely been run. And now we will move on to look at the features and all. So first of all, before we start, let us see the head. So iris dot head. Iris dot head. Let us see what iris shows. Okay, iris dot head is not defined. No worries. Even if it is not defined, we will still work on it. Okay. So moving on with this only, let us load features and labels. So X will be the features that are being stored iris dot data, and Y is iris dot target. Okay, so data, what is data? Data means the features. Features, what are the features? The sepal length, sepal width, petal length, and petal width. And what is the target? The target is the classification of flower. Correct. So now we will move on with printing it. So print, first of all, the feature names, features. Okay, features. Then print iris under iris dot features names. Okay, and the next one will be print, and in print we will write target names, target target target, and print in print we will be writing the iris targets, iris dot target names, okay. And after this we will also see the shapes of both of them, okay. So we will also write that thing, print, and in print we will write feature shape, uh, okay, feature shape. And we also need the label shape, we also need the label shape, LAB, okay. And in here I am going to write the x dot shape, print x dot shape. And here in the last one we are going to write print y dot shape to predict the labels shape, okay. So when I run this particular, there seems to be problem. Okay, why should be defined capital here? Was giving the error due to that thing. Okay, so sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width in centimeter. These are the features which are being involved. What are the targets? Targets are setosa, versicolor, and virginica. These are three different types of flowers, or three different types of iris flowers that we are going to detect. Then we are moving with feature shapes. What exactly is the feature shape? Feature shape is 150, 4. 150 are total number of data points that we have collected. 4 are the different column names. So these are 4 different column names: sepal length, sepal width, petal length, and petal width. 4 different column names. Then we have label shape. Label shape 150, 1. 150, nothing. That means 150, 1. That means there are 150 different types of flowers that are being classified in this particular data set. Now we will display few 5 records, first 5 records that we have. So for that we will write print, print, and here x, and in square bracket to 5. When I run this, these are the first 5 records. So what are the first 5 records? So these are the first 5 records. First of all, we had sepal length. So this is a sepal length 5.1 centimeter. We have sepal width 3.5 centimeter. Petal length is 1.4 and petal width is 0.2. These are the labels. These are the features. Similarly, when we want to see the for the labels, print print y, sorry, capital Y, and in square we write is to 5. We'll print as the values of that as well. 0 0 0 0. That means the first values are maybe of a particular kind. Let's say they might be of setosa. So first 5 are the setosa type of colors, type of flowers. Now moving on, we will split the data into 2 phases, the one being training and the other one being testing. So how did we do that in the previous lectures? So first of all, I'll create this train test train test split. And then we will move on to create a code for that. And in this, we will write x underscore train, comma, y underscore train. Then okay, so okay, here we need x underscore test, y train, and y underscore test. Okay, so we are going to define this as a function. So what will be the function? It will be train underscore test underscore split. This is the library that we are using, and in it we have x, comma, y, comma, let's say we divide it as per 0.80% in training and 80%, 20% in split. So here we will have to write test size. First of all, test underscore size, test size, let's say If we want 20%, we will have to write 0.2. And random state, random underscore state equals, let's say 42. Okay. Now moving on, we will also have to print the training samples and the testing samples. So print, we will have to print first of all the training samples, and in training samples we have to write comma length of x underscore train, and similarly we will also have to do it for testing. So for that it will be testing samples and x underscore test test. Okay, I comma forgot the comma here. So training samples is 30 and testing samples is 30. Now we will be moving on with the models creation. We will move on with the creating the model. So for model creation, I'll just write here text model creation, and under that there will be the code box, and in code box model we want to use is k neighbors model classifier model, and in this we need to have n neighbors equals to 3 because there are 3 neighbors, correct? What are the 3 neighbors? The different types of iris flowers. Okay, now we will move on to fit the model. So model dot fit, and in this we will be writing x underscore train and y underscore train. Y underscore train is not being defined. Okay, okay, there was a slight this. So instead of train, I have to write capital train. So it is going to train, and we have got our k neighbors classifier running. And now we are going to the model has been trained, and we are going into prediction. Okay, so we will write a new text box with prediction, and here prediction. Okay, and in this we will add a new code line y underscore pred equals dot predict model dot predict x underscore test. Okay, test. Okay, now we are going to write about the actual labels which are on it. So print, and in print we are going to print the actual labels, and actual labels are going to be y underscore test y underscore test. And how much do we want? We want the first 10 numbers to be printed, so here I'll have to write is to 10. Okay, and we will also write about the predicted ones. So these are the actual tests, and we also need to write about the predicted ones. Sorry, we also need to write about the predicted labels. So predicted labels are going to be y underscore pred. Okay, let us write here since we need to maintain what we have started. Okay, so instead of small y underscore small pred, we'll write here y underscore big pred. Okay, okay. So this is going to print us the predictions as well. Now we are going to run it. So running it gives us these particular labels. So these are random labels. These are not, the machine learning model is not looking into it. It has learned the values. It has learned to draw a particular pattern and it is predicting. So as we can see, first of all, it might have been the second type of flower. Here is the second type of flower. This is the first type of flower 0. This is the first type of flower 0. Similarly, the first 10 flowers have been predicted, and here as well the first 10 flowers have been predicted. These are the actual flowers actually. These are the actual flowers and these are the predicted flowers. Now we are going to check the accuracy score. As we can see already the accuracy is 100%, but still we need to present it mathematically. So we are going to write here accuracy score, and in accuracy score we have to write here the formula for it. Accuracy equals accuracy score, and the function will be defined as y underscore test, y underscore test and y underscore pred. Okay, and then we are going to predict the model's accuracy. So how are we going to present? Print, and in print we are going to write model, model accuracy, and it is going to be presented as accuracy into, because accuracy will be presented in decimal form, we need to write it in percent form. So it will be presented as accuracy into 100, and for that also we need to give it up till 0.2 fractions, 0.2 fractions, right? Here as well, and here I'll have to write f. Okay, here percent sign will be necessary. Okay, so when I run this particular, we get model accuracy as 100%. So all the actual labels and the predicted labels by the machines are matching. So that means that we have got 100% accuracy. Let us take few sample flower predictions as well. So let us write here new text, and in this sample predictions. Okay, sample predictions, and let's say we take few samples such as, first of all, sample underscore flower. Let's say it is 5.1. Let's take this as sepal length, 3.5 as sepal width, comma, we need also need the comma here. Then we need 1.4, which will be the petal length, and let's say 0.2, which will be the petals width. Or let us change it to, let's say 0.4, or let us take 3 instead of 3.5, let us 3.2, and instead of 1.4, let us take 1.6. Okay, so this I guess is random, and because it is random, it is going to give us the random prediction. We don't know what the answer is going to be yet, we will have to check it out. So we will write here prediction equals model dot predict sample underscore flower, and we will get the prediction class number, which is print. We will have to print the prediction class number, which is going to be prediction, and it should start with 0. Okay, So control enter. Prediction class number here is 0. What if I write here 1? Nothing. So we have to write here 0 only. What if I change this to, let's say, 3.1? What if I change this to 2.6? Okay, all are giving a 0. Let us take something else now. Okay, let it be. Now what if there are multiple flower predictions that we need to do? So also write, let us also write a code for multiple flower predictions. Multiple flower predictions. Multiple flower predictions, and for that we need to add a code line as well. And in code line we will write flowers. We will have to pass the input as an array or matrix. So for that we will need to form a matrix. So let us take a random matrix, mapping it randomly. Okay, this is a random matrix that we have taken, in which the first column represents 5.1, 6.0, and 6.9. These three numbers, they represent the sepals length. Second is sepals width. The third is petals length, and the last one is petals width. You guys know the remaining drill. We have to predict now. So predictions. For that, it is going to be model.predict in bracket flower. Okay, we'll also have to create a loop for this because this is going to be enumerated. So for I, we need to write predict in enumerate and predictions. This particular function, which is predictions. Okay, and next we have started the loop and print. So what are we going to print? We are going to print first of all the function which is flower, which is I plus 1, and this is going to give us the iris target's name, that is class name. So here I'll have to write here iris dot target underscore name, and in names we need to find the prediction quantity. Okay, so that completes our for loop. Control enter. It is giving me some error here, which is predictions equals model dot predict flower. Okay, flower, instead of flowers I need to write flowers. Okay, so the first one was setosa, second flower 2 is very versicolor, third is virginica. Okay, so these are the names of flowers. Let us input one more flower, the first one which we input here. Okay, so let us try this one as well, comma, then here we need to write about this, correct? This as well. Okay, so when I press Control Enter, it is going to give me additional fourth flower as well. So fourth flower was at setosa. That's why here it was printed class number is 0. Correct? So when we move on, let us have a confusion check as well. Okay, so here we'll write about confusion confusion check. We will add a code in which we will define correct as keyword, which is numpy dot sum of all the correct values. What will be the correct values? Correct values will be y underscore test when it is equal to y underscore predictions. Correct? So y underscore test and y underscore predict If these two values are correct, then only it will be added in the correct field. If they are not correct, they will not be added in the correct field. And total correct. We also need to identify the total correct fields. So that will be length of y underscore test. And next we will have to write print correct predictions. Correct predictions. And in this, we will have to write correct and total predictions. Here we will have to write about total. When we run it, there are total 30 correct predictions and there are total 30 total predictions. So accuracy, what will the accuracy be? Accuracy, print. In print, we will have to write about accuracy. Accuracy equals to the correct divided by correct divided by total. So this is our accuracy, which is 100%. So that completes our second session. What all things did we learn in the second session? So first of all, we started with the basics of NumPy, in which we understood what NumPy was used for, how it was used, and there were different things that we studied about it, the arrays, the matrix multiplication. Then we moved on to look at features and labels. Then we split the data into two sets, which was training and the other one was for testing. We also did applied classification model, which was k nearest neighbor classifier. Then we also looked at the accuracy, checked the accuracy of the model, which came to be 100%. And the last one, we tried to predict the iris flower. Now, that is a fantastic work that we all did. Today we build our first classification model. Yesterday we just predicted marks. Today we classified the flowers. And in the upcoming session, we will move closer and closer to the real deep learning systems. If you enjoyed this particular session, make sure to leave your doubts and questions in the comments. Don't forget to like the video, share it with your friends and subscribe to my YouTube channel. Also explore Ingiverse, where you will be finding all the recordings, assignments, quizzes and certificates along with placement resources and get preparation material and technical courses as well. And if you're interested in learning more, do check out the Sahil at Work YouTube channel, where I regularly publish videos on algorithms and data structures. There is data science with Python, there are concepts of microcontrollers and microprocessors. I have also worked on signals and systems. Thank you everyone, and I will see you in the next session where we begin building actual neural networks. And one more step, moving one more step towards our deep learning goal. Until then, keep learning, keep watching, and keep growing. Adios.